Welcome to Project Brewpeg. My name is Damien. We're converting a sunken fishing trawler into a global expedition and research boat. We're community funded and you can get on board. This episode we're setting up our Red Arc gauges in the wheelhouse and in the engine bay. There's a particular brand of gauge that we wanted to use on Brewpeg. They're called Red Arc gauges. There's a couple of reasons why we wanted to use these. They've got some really great safety features in terms of their programmability for alerts, and they're also built really strong. So they've got a really great reputation when it comes to all sorts of vehicles. So it could be anything from like a race car right through to a four-wheel drive that goes off and does big week-long camping trips and things like that. So they're able to handle really rugged and tough environments, and that's one of the reasons we chose them. We contacted Red Arc and they were really excited by the project, so they actually offered to supply the gauges for the boat. So there's a sponsorship deal going on with these gauges, and we're over the moon with this. One of the reasons why we were really keen with these guys is because it's an Australian company, the gauges are made and designed here. They have like technical support, so we were on the phone to them quite a few times trying to figure out different bits and pieces, because we're doing some unusual stuff on Brewpeg with these gauges. And they were awesome because they knew the gauges so well. They were able to help us out really well. So a big shout out to Red Arc. It wouldn't have been possible without you guys. So there's a few people that I want to thank. There was a huge amount of work involved in getting these gauges up and running. Before we could even touch the gauges, we had to get the prep work out of the way. Adam came up from Brisbane and gave us a hand to run our 3-inch conduit, which allowed us to take the cabling from the engine bay right up to the bridge and to the battery area. Clint followed after that. He came up and gave us a hand to mount our distribution box on the wall and then run all of the cabling that we need to get the gauges up and running from the bridge right through to the engine bay. And he also helped us take care of a number of problems we had with the engine that we didn't realise until we got stuck into it. And finally, Richard flew in from Vegas. He's one of our Patreons. He's a US military trained avionics electrician. What he doesn't know about electrics isn't worth knowing. He came in and gave us a hand to terminate all of the cabling, run any additional cables that we didn't know that we needed at the time, and set up all of the fusing and the gauge systems. He helped tune the gauges, and then finally we were able to get all of the gauges up and running. So I really wanted to say thanks, guys. It wouldn't have been possible without you. So without further ado, let's get stuck into it and have a look at what we did. So Brewpeg's engine bay, what we're doing is hooking up the wiring. So Adam's come up from Brisbane for the weekend, and we are hooking up the wiring that goes from all of the controls in the engine through up into the bridge or the wheelhouse. In order to do that, we need to basically run, what have we got? We've got 50 individual runs of wire. That's with no redundancy and no spares or anything like that. So we're going to be running about 80 to 100 wires between here and the bridge, just so that we've got bucket loads of redundancy. And we're also going to put them in separate strands of wire. So the wiring that we're getting is, I think it's 17 or 18 core. So basically that's, if you don't understand wiring, like me, it's basically one individual core of wire. Imagine there's 18 of those in a group, and then that's all strapped together. That's one of the 4 strands that we're running. So we're going to be running, quite a few wires between here and the bridge. We have to run it up in a pipe. So we're using 304 stainless mandrel bent exhaust. So it goes through this bulkhead, goes forward, and then sort of wiggles itself around until it's just underneath the floor of the wheelhouse, and then it goes directly up through and into the wheelhouse. So the engine bay and the wheelhouse will be connected by this pipe.
Keep talking good, keep talking sweet, keep sugar on, baby. I got you good, I got you sweet, got you.
Clint is here. He's about to do cable trays throughout the engine bay. So we're mounting our cable still, and he's basically going to be doing all of the cable runs. We've already glued down the mounts that go up in the battery box so that we can pop rivet the cable trays to some aluminium mounts that we made, and we're now just doing a similar thing in the engine bay so that we can keep our cables nice and controlled. So let's get stuck into it.
Keep rhythm on, baby. You got me good, you got me sweet, got me on.
So with the box welded in, you can see the weld at the top, and then if you come down to the bottom, you got the weld all the way around the bottom. It's pretty manky, so if you see right up in there, the weld's going to be too rough for wire. We need to clean that up. It has to be a nice smooth surface so the wire doesn't chafe. So we're going to go through now and flapper it on the inside, and then we're going to die grind out the actual inside of the tube so that we can make sure that we've got a really good surface for the cable to pass through.
Okay, it's good for you to pull on the rope.
Baby knows what I'm all about, and my baby knows.
Okay, that's it there now. Perfect.
So this is the tray where it sits. You get the little alloy mounts. They basically they silicone onto the wall to silicone adhesive. They adhere onto the wall, and then we start to run our cables through. So over on this end, they'll be coming across and going over onto there's one set of wires that goes to the auto pump up here. Autopilot, and then from there it splits off and starts going down to this end of the engine to all of the various controls and gauges. We've got cables going in all different directions. We've got a stack that are going straight down along these cable trays. We've got some that are going to the roof for lights, and we've got these big black ones that are going out to the side and along the side of the hull for our AC. The AC is being kept separate from everything. So we're just going to run the last cable tray for the day. The ones are in the wheelhouse are done, and now we're just doing the last few in the engine bay, and we can start running the last of the DC cable. The reason we're doing these now is because we don't know how long to cut these cables, so we're doing all of this grey cable that's coming down here. We don't know how long to cut them, so we're running all of the cable trays so that we can feed it where it needs to sit, and then we can cut it to the exact right length.
And where does that one go to?
The grey one goes from here through the conduit up to the bridge, goes through the wall into the kitchen, up the wall and across the roof, and then up behind the dash, and then to all of the gauges and alarm systems and stuff, because they're all in front of the driver. So easiest path is basically via the wall in the kitchen. We're getting that done now, and we've got another few that are once they come out of the conduit in the bridge, that are AC, and also some of our like switching and some of our warning signals and stuff. They're all going actually above our heads. So there'll be a couple of different runs going in different directions under the floor of the wheelhouse. Pull red and pull black.
Yeah. We've got two wires here. I actually think we only need one of them. It looks like they do the exact same thing. They go to the same place at the top. So
Sure.
We'll hook these up here. Back at the battery box, we'll have a look at what we need to do. It looks like we don't know what this alternator is, but judging by it, there's heat sinks and stuff on the housing, so we can assume it's got an internal regulator.
Yeah, right.
Therefore, we don't need external regulation. This here is more than likely just I would say the two contacts are probably one for the alternator light on the dash to know whether or not the alternator is working.
Yep.
And the other is to go to the RPM gauge, but because of the internal regulation, they're both just
doing the same thing.
They're both doing the same thing. It's basically just getting an AC signal before it goes through the regulator.
Okay, cool. So we can those cables are marked. I mark them on the other side of the battery, so we can tell which one's going where.
Which one goes where? We should be able to use the same one for both. Wire here. This will run to our alternator light and gauge. Okay, so we'll put these three into there. So we want to check what the voltage. We've got 12.55 now.
Yeah.
We want to see if that increases once the engine starts, and we want to check what the light bulb does, and then we'll shut the engine off.
Alright, so power up.
Yep.
Yeah. Yeah, fuel's on, cool. Real clear. Neutral. And the motor wouldn't turn off because we found a problem with the solenoid. fuel screw solenoid to turn it off didn't work. We couldn't actually turn it off.
There we go. Okay.
First issue was we really wanted to work out what's going on with the fuel solenoid, why didn't it work. It hasn't worked for Damien at all yet, so we really wanted to pull that apart and find out what's going on. After pulling it apart, seeing how everything works, we've now bolted back together, started the engine twice. It starts and stops perfectly, and we're now good to get back to checking the alternator.
What's it doing? Smoking? Oh wow, yeah, smoke.
After our old drill died, we bought a new 2-speed battery drill. It was awesome. Through.
So, is the drill warm at all?
Oh, slightly.
Slightly.
It's just raised the temperature.
Oh, what's like
I don't know.
lukewarm?
10 degrees above ambient.
Yeah.
Alright, so let's maybe clean that out then.
Drill's hardly bothered.
Yeah.
You're
I'm more bothered.
breaking a sweat.
Yeah, I'm more bothered than the drill is. So on our dusty dash, this is where the cables basically terminate. You see the ends of them there. They come up through this hole. That down there is basically the kitchen. You can, maybe if I can get the camera to focus, you can see in the background is the kitchen. And then back up here, this face here is where all of the gauges sit. So if I spin around beside me here, that there is basically a board that I made that has all the gauges, and then we've got some space over on this side here for an extra screen if we need it. But for now we've got 5 gauges that sit just there. So these big thick grey cables basically are 18 conductors, so 17 conductors plus this single earth. We're not going to be using the single earth in any of these cables, we're going to have a separate earth. We're actually going to be using these as a tester for continuity later on, so if we ever need to figure out you know, if we've got a break in any of the cables or anything like that, we're going to keep this one spare so that we can always run current up this one. At the other end we'll join it to whichever one that we're trying to check, and then we can run essentially a circuit all the way around. So we're keeping this as a spare for later. If we desperately need it we can use it, but most of the time we're probably not going to have anywhere near that level of stress. We're going to have plenty of redundancy. So you can sort of see there's quite a few of these conductors in each of these grey cable runs. We're going to be using these type of terminal blocks, so they're going to be fastened down behind the dash here, and then each of these cables is going to be terminating in one of these. Now we use, not this size, but gives you an idea, we use these things here, ferrule bootlace connectors. They're brilliant. They basically stop the strands of the wire breaking.
Keep talking good. Keep talking.
Okay. So, if you've never used multi-core wire before, this is actually the first time I've ever used multi. There's a couple of things you need to know about it. Basically, it has numbers on each of these strands, so they're all black insulation on them, so there's no way you'd be able to tell one wire from the next. However, they have numbers marked on them. So in this case, you can see 1, 2. Let's go to a different one. 5, etc., etc. So what's that one? 8. So every single conductor has its own unique number. We have 3 of these big cable runs going up to the bridge. So we have the main numbering is 1, 2, and 3, and then inside each of these we've got 1 to 18. So whenever we need to troubleshoot, we can always basically figure out what's the main conductor number, and then also what's the minor conductor number, and that's how we solve our wiring between the bridge and the engine room. So, green is number 1, black is number 2 and 3. So Rich is back over from Vegas. We are getting stuck into our engine bay wiring. So there's chaos everywhere around the battery with all of those wires going around. We're just trying to figure out where everything goes, what we're doing with it. And this, if I spin around, all relates to our stainless box that we put in a few weeks back, and the cable runs. We've got all the cable trays and so on running around the engine room now. So we now need to start figuring out what we're doing with our wiring, our harnesses, and how we're going to extend some of them. What's the name of the wire that you've been using?
It's a Luminel Chromil wire. It's been around for a long time.
Yeah. So the wire that we're using is pretty specific. It's for the exhaust gas temperature sender, and we can't lengthen or shorten it without screwing up the readings in this gauge. So what we're doing is we're modifying the gauge to suit the length that we have to use for the sender. We're also making a couple of boat modifications, so we're putting on some military grade heat shrink onto this so that there's no chance that any water is going to get into these cables. One of the things that we're doing to it is basically moving the sender box. There's a little box that all of the senders plug into. We're moving that closer to the engine, and then we're extending the cables that go between that box and the gauge, and that's the only way that we can actually get the gauges to work in BrewPeg, because the wire runs are so big. So speaking of long wire runs, Richard's up in their wheelhouse here, and we're going through and organising all of the different gauges, how the wiring looms plug into our extensions up at this end. So these are our extension blocks here, our big 18 core conductors. They run down into the engine bay, and then these little looms here are for the individual gauges. So we're just going through and basically figuring out how to plug all of this together. We have 5 main gauges on BrewPeg that tell us the condition of the engine at any given time. We have a volts and amp gauge that tells us the condition of the start battery as well as the condition of the alternator. Those two things are important because if the voltage on the battery is too low, we won't be able to start the engine again. If the amperage is too low from the alternator, we won't be able to charge that battery after we've started it. So those two things are really critical to be able to maintain the ability to start the engine whenever we need it. We also have an exhaust gas temperature gauge as well as a boost gauge. It's the 2 readings on the 1 gauge. Boost tells us how much pressure we're creating from the turbo, which also gives us an indication of how much load we've got the engine under. If we've got a lot of boost, the engine will have a lot of load on it. The exhaust gas temperature sender and exhaust gas temperature gauge are very important for us because we run on veg oil. We need to know how much load the engine's under, and the EGT gauge, or exhaust gas temp, the EGT gauge is really important to understanding a diesel's engine load. If you've got a low exhaust temperature, you've got a low load on the engine, and for us that means we have to switch back to diesel. If we've got a high temperature, we've got plenty of load on that engine, and that means we can run on veg oil. So for us, that's a really critical gauge. The final gauge that we have is a dual water temperature gauge from Red Arc. So the dual water temperature gauge is really important in terms of how efficient our cooling system is running. So we can monitor we can monitor the water that's going into the engine as well as the temperature of the water coming out of the engine. So with those 2 measurements, we know how effective our keel cooling is, whether we're in the tropics or in the polar conditions. We have to alter slightly how much water is allowed to go into the keel cooling depending on where we are in the world, and that gauge allows us to know exactly how effective our cooling system is running. There's 2 other really important gauges that we have on BrewPeg. We have an RPM gauge, which revolutions per minute. It tells us how fast we're spinning that engine at any given point in time, and that gives you an indication of engine load as well. So a high RPM on a diesel generally means that you've got a reasonable load on it, and a low RPM means that you're obviously, there's not a lot of load on it. Now, that's a bit different in a truck. You can spin something fast and have low load, but in a boat, it's a constant revs engine. You've either got load or you don't have load. It's very, very simple. Oil pressure is the last gauge that we have, and it's possibly one of the most important. So oil pressure is the single biggest factor in an engine having catastrophic failure. If you lose oil pressure, you lose all of your lubricating ability in that engine, and it's only a matter of seconds before the engine will completely destroy itself. On BrewPeg, we have a couple of ways to safeguard so that we never lose that sort of information. On BrewPeg, we've mounted an analog oil gauge directly into an oil gallery, so there's nothing that can fail in the system except for that 1 gauge. There's 1 moving part in this whole system, and that tells us, independent of all other systems, how much oil pressure we have. We'll also be putting another electronic sender into the engine, and that allows us to have an electronic gauge sitting up on the wheelhouse with a measurement of oil pressure. Now, a really, really critical thing that you need to do if you're setting your boat up with electrics like this is an alarm. It's very easy to miss a gauge dropping off. If you've got, say, 40 pounds of oil pressure and then all of a sudden you've got no oil pressure, it's very easy to just be driving along and not actually see a gauge drop down. So you really need to have something, either a visual or an audio alarm, something that just is noisy as and it screams out at you to go and deal with it. Some people wire it up so that if the oil pressure drops off, there's an automatic kill switch on the engine that stops the engine. That's good and bad. If you're coming up against a reef, doesn't matter if the engine's going to destroy itself, you do not want that engine to stop. So there's pros and cons with that sort of system, but definitely have an alarm no matter what. If you're going to run out of oil pressure, you want to know about it. The beauty with the red arc gauges is if they go outside a set parameter, like say voltage for argument's sake, if you're running a 12 volt system and you can adjust all of these parameters, but if it goes down to say 11 volts, the gauge will actually start flashing red. So it's a brilliant visual representation that something's out of a set parameter. So that's one of the reasons why we chose these gauges is they're really good in terms of reliability. They're built really well, but they also have some great features that allow you to have some really good sort of safety built into the whole thing. So one of the thoughts that we have, Brupeg has 5 different voltages in this boat. So in order to minimise issues and so on with like crossovers and symptoms in one system, one voltage turning up on others, we're going to eliminate all of the house bank from this wheelhouse area. So all of the gauges that you see, everything basically to run the engine and run the boat up on this dash area is going to be run from the 12 volt system off the main engine, and then the only thing that's going to be run off the house bank in this area will be lights. The reason we're doing that is house bank is 48 volts and we want to keep everything as isolated as possible so that we can increase reliability. There's 18 wires in this, so it's 17 of these black wires and 1 of this green and yellow, so it's called 17 plus earth. What we're doing is each of these is numbered, so you can see in this case it's very hard to see, but there's a 15 on that conductor there. If I pull it over, there'll be a different number on whatever it is, but each of these black conductors has a different number on it, and that's how we can tell if we're working on, say, conductor number 3, we can go down to the engine room and pull conductor number 3 and we know it's exactly the same wire. We've got 3 of these big grey runs with the 18 conductors inside each one, so we've numbered these like 1, 2, 3. So we first off decide which of these big conductors we're working with, big cables we're working with, then we drop down to a conductor level, figure out which number we're working with, and then we know that we've linked up between the 2 rooms. We've also got positive and negative coming into a bus bar up here, so this is essentially the positive and negative off the start battery in the engine room, so then we're running all of our feeds and everything from that one bus bar.
It's a half step.
Yeah.
And
hold that.
Dane's on a lunch break and he just needs to paint a few things, so for timing, so we're using the lunch break.
I need you to
Hours?
see how the wires are tight one side or tight the other side, depending on where this is. This way or that way.
So we need to middle it.
Yeah.
Yeah.
I haven't yet decided how I'm tying that.
Pretty good there.
Or I think I want to flip it and go like that.
All right. What if we undo the zip tie and pull it a bit more like that, so that we've got more space here with the wires? Because that zip tie is just holding it randomly, or we can just get rid of that.
Yeah. And I can relieve that sheathing more too.
Yep.
When I need to.
It's like a little puppet show.
Yeah, you're pretty good on all of the wires.
Hey, 10 minutes to secure one wire.
Boat.
Boat. It's basically the vibration of things doing this for
Yes.
decades that will make sure that fails.
Right. Alright, so that's why we're clamping the crap out of it.
Right.
Alright, cool. Rich is making some pretty good progress, so you can sort of see we've got our fuse holder up the back there, we've got our distribution board where we can sort of splice our wires into, and then we're starting to label out each of the wiring harnesses for the gauge. But we have found a problem. I'm just going to zoom in and show you. So right down low, so he's just stripping off some wire here, but you got one of those little fittings that you just showed me, wherever it is. Oh, so these little fittings here, bootlace lugs, they're called, and we use these to terminate a wire. So we'll strip a wire and then we'll slide one of these over it and crimp it. Now, I did a whole bunch of these when I fitted the big 18 core cables into our connector blocks, and we just realised that a whole bunch of them are failing, so we're ripping them out now and repairing them, putting in. Basically the crimper wasn't set up right when I did it, and I didn't know this, and we've learnt it now, so we're replacing everything. So this crimper is what we use, and it has this little adjustment cog just down in here. This little adjustment cog here basically goes from 1mm up to 6mm, and it wasn't set tight enough to squash the 6 jaws together. Do you need to squash them together? There we go. So that's what it does. It basically crushes that central jaw together. So when I did the bootlace lugs, they weren't crimping tight enough, and some of them are failing. So we don't want that as a point of resistance, and therefore a point of moisture and failure and so on going forward.
So when you're stripping the wire, you want the wire stripped the length of your piece you're fitting, so that the back of the insulation butts to the back of this and protrudes to the front. So when you crimp, everything gets crimped, and the shielding actually helps you strengthen the copper, if that makes sense.
Okay, cool. So do you want to slide it on and actually show you?
It's right at to the end. That's
Yeah,
where you want it,
right
to
at-
the end.
Okay,
So that when you crimp, you're getting, there's 4 crimps in here,
okay.
and so when you crimp it, it crimps in all 4 locations.
Right, and that's what you're left with. We also wanted to show you the difference between a couple of different types of crimpers that we use. So these are sort of the automotive type crimpers of the world. So you've got basically fairly tough jaws, and they protrude quite far in when you squeeze them up, and they're for these types of connectors. So the plastic around these connection terminals is quite strong, so you do need something with a bit of grunt to be able to squash these down, and that's why you end up with jaws that look a bit like this. In the marine environment, you need to protect against corrosion, so you need to use something along these lines, which is a heat shrink type connector terminal. So each of these terminals, the plastic part is quite soft, and it has a resin embedded in it, so once you crimp it, you need to be able to then heat it, and it seals up on the conductor insulation as well as the actual terminal, so it gives you the best chance of actually preventing water going into your cabling. The reason why these are different is if you have a look at the teeth on these ones, I'll just go back to the teeth on the other ones, you can sort of see they're quite different in terms of design, and the reason being, when you crimp these right down, they don't squash or pierce the plastic surrounding the actual terminal. It's very easy to damage these terminals because they're quite soft, and you don't want to put a hole in them because then you're just going to get water back in that hole. So the point is, you need to squash the metal without damaging the actual plastic surrounding it. So when you start crimping an automotive terminal, you end up putting a fairly decent dent into it, but if you sort of see that, you've ended up mashing the terminal quite a bit, and there's no real way to stop water getting in that. That's, if you put that on a boat, eventually that's going to fail.
That is a best case 1-year connection.
That's quite a good way of clarifying it.
Yes.
And if this is outside, that's a best case 1 week connection from personal experience. So with these ones here, when you've got the heat shrink component, you can squash it down and then very much seal them up. So not all terminal connectors are built equal. So this is a reasonable brand, reasonable sort of terminals and that sort of thing. These are the proper resin infused heat shrink, and they're about $55 US for a 500 piece set. Now, these ones down here are absolutely whiz bang. So these, look for that label ABYC when you're looking for your terminal connectors, and there's a very good reason. They're not cheap. These are about $10 for this little packet, but there's a reason why there's a big price. So these are the 2 different options side by side. So you see the one on the left, the resin infused heat shrink goes right down over the terminal, and the one on the right, you can sort of see there's a bit of a gap. If I come down the end, you can see it much clearer, so you can see through to the bench that that's sitting on.
And what happens is when you shrink, one end goes like that with wire hanging out the back where corrosion can travel up the wire, and the other does not.
So the issue on a boat is you're always fighting corrosion. You've got atmospheric salt and a whole bunch of things like that are basically trying to corrode your metals at every opportunity. So if you go down the road of using something like this, you haven't protected the wire to stop the moisture being able to travel up that conductor. So it may look like it's sealed up, but it's not going to last. Whereas if you have something that has a resin infused heat shrink that goes over top like this, you're going to have a much stronger connection, you're going to have a much higher reliability. What are you doing? Me? Wait.
It's gonna get toy first.
Hey.
A second-hand Mac arrived after our computer died.
That's two.
Drone's okay. It's alright.
Outside with the quiet, put the drone room to relax.
So to put some context into this, Ryan's flying the drone around. Mish has a particular phobia for this drone.
If we let her go,
Piss off with your drone! So we pulled all of our cabling through and we basically just left a big long run, and Richard's brought up a really valid point. He doesn't want to cut this, he wants to leave it as long as he can. So what the plan is rather than chop it off shorter at this end, we're going to pull it through the conduit and do a big loop in the wheelhouse, under the floor of the wheelhouse, and that way if we ever need any more conduit for whatever reason, corrosion or anything that we have to deal with, we can basically just pull it through and trim it to length and so on. So where are we at with the wiring? The harnesses for each gauge have been completed. So we've got one, this one over here is our rev counter. We've also got each of the Red Arc wiring harnesses here have all been wired up to the appropriate areas. So up here we've got all of our positives, so each one is fused, and then down here we've got all of our sender cables. So each of these sender cables is basically an extended loom. So they come with a factory loom, and we needed to extend it obviously for BrewPeg. At the other end of these cables is the stainless box. So let's go and have a look where these go on the engine. So the plan for this cabling, Richard's basically marking out which conductor goes to where. The reason we can do that is it narrows down. We know we've got spare conductors. We also know that we've got our main conductors that are providing our signal cabling and so on. They're coming down onto connector blocks over the back here, and then all of these connector blocks have our resin infused heat shrink connectors. So the next steps from here is we need to figure out exactly how we're going to route all of the cabling that goes from that stainless box across the engine. So it leaves the stainless box and goes through cable glands, and that essentially stops any moisture being able to bypass the cable and go into that box. That box is going to be sealed watertight, and we're going to have a clear outside window on the front area so that we can see inside. We can see if there's any drama going on there. We can see if there's any condensation, rust, drips, anything that would make us raise any red flags. It's all going to be visible, none of it's going to be hidden. So this little control panel that sits underneath the battery box is where we're going to be seeing all of our gauges. So these are the same Red Arc gauges that we had in the bridge. There's a duplicate set down in the engine bay, and it's so that we can basically see exactly what's going on with the motor no matter where we are, whether we're right beside the engine or whether we're up in the bridge. We're going to be fitting the rev counter up in this clear space over the back here, and then also an engine hour meter in there as well. So it'll be a duplicate system from what's in the wheelhouse.
too short, too tight. Quality strips. See how I melted them? Didn't even realize it. I was like, holy fuck.
Holy fuck, you have to. I didn't even think that was a thing.
What?
I didn't even realise that they would melt.
Neither did I.
Thankfully where we are on Brupeg we've got a chandlery just over the road, so we can get any sort of electrical connections or ropes, fenders, chain, any of that sort of stuff. If we need little bits and bobs, bolts, it's great for that sort of stuff. I quite often use it for paint. So yeah, we're halfway through our electrical fit out and obviously we're missing some bits, so we're going for a walk. So under the wheelhouse, where our batteries live, our cable trays, you can see over the back there's loops for the cables that go down from the engine room up into the bridge.
This is Richard's heading downstairs for some work down in the engine bay. Just a few things. Wow.
It gets pretty warm working in these spaces. So we've got our cable tray mounted against the wall for our AC. We're just waiting for the adhesive to dry. So that's actually basically glued to the wall with a really strong adhesive. Every rib has a little right angle piece of alloy behind it that basically glues that 75mm cable tray to the alloy, which then glues to the rib. So what the plan is now, Richard's working on getting that grey cable you can see there is a 18 core conductor. So that's going to be going down to these cable trays down the bottom, which then basically follow along the front of the engine bay, right round there, and they help go over to all of the sensors and so on the engine. We're still trying to solve on our exhaust manifold here, so that sender is for the exhaust gas temp. You've got the turbo just here, and then where the manifold basically ends, you've got two bungs. We're trying to take those out so that we can put the sender in, but those things are well seized, so we've just been trying to soak them in diesel over the last few days, but we're probably going to start trying to use heat and potentially even weld something onto the top of the on top of the bung itself and use that heat to actually get it out. But yeah, we've got a few options that we'll try. Either way, that's something that we're struggling with at the moment to get out. So what we're trying to do, up the top here, this is on the exhaust manifold. You can see there's these two little bungs, and we probably don't think that they've ever been taken out. It's a cast iron manifold, so you kind of get one shot at it, and if it doesn't go well, it really doesn't go well. But we need to take these out to put the exhaust probe in. So this is going to tell us what our exhaust gas temperature is for the red arc gauges.
I got a lot on it.
Not budging. So Richie is doing mindless stuff apparently, putting on stickers. So what we ended up with, this is our fuse assembly, starting to get some cabling going up into it now, but you can sort of see we've got positive and negative at different top and bottom, and then obviously grommets where it disappears through out into the back, and then in the back there's a bit of a morass of cabling and stuff, but it's all going to be sort of tucked away and coiled up neatly down the back. So Rich just had this bloody awesome little tool that he whipped out. So it's essentially a wire brush, but it's like an internal wire brush, and it's got a pipe cleaning type arrangement, but it's for battery terminals. This is what it looks like when you basically buy your battery and your skanky old terminal. You pull the little plastic caps off, and that's roughly what you're left with, and this is what the tool turns it into. Beautiful shiny lead. So you're going to get a much better connection by having that, and it's a piece of cake. Do you want to buzz that end one? literally all it takes to get that looking really beautiful.
Same deal.
So what happens if you don't do this?
You build in resistance.
Okay.
You build in problems.
Alright, so the plan, take these, weld to these, and the heat from welding transfers through into this, expands the metal out, and then you can get a bigger surface to start cranking on, bigger spanner, etc. And it's only a small thread, so theoretically it should come out. However, as Richard so eloquently pointed out earlier, it takes big nuts to do that. So you need something that's going to ideally go over top. So in this case, it just fits nicely over top of that stud, whatever bit of that stud is sticking up. Fits nicely over top, and then you can fill that up with weld, so you get a really good bond to the top of that stud, but you also get lots of heat soaking through. Doing it this way, rather than say drilling it out, you don't get any garbage going into your turbo. So if you're going to drill it out, you have to move your turbo out and seal it off and do all of that sort of stuff. By doing it with heat like this, you don't have to take the turbo off, because there theoretically won't be any rubbish going into the exhaust manifold that the turbo can't handle. There might be a bit of carbon or something like that, but that's okay for the turbo. Right, so let's get into welding. Yeah, holy shit.
Yeah. Fan's back on.
Didn't plan this. I'm just going to weld the shit out of the other one fast and just get this out. So, I also need a big spanner if you want to go. Okay. Put a bit of diesel on, and she comes out. Part of it comes out. And that didn't work at all.
There we go.
Fuck me, no, that's not coming out. I just made a thread.
Did that one actually move?
Nope.
No, the other one.
Nope. Not on the window. I built the thread though. Sucks. Fucking hell. I thought that was going to be magical.
Too little.
We got movement. I think I might be taking the weld off it. Yeah, take the fucking weld off it. Man, they don't want to move. So last time I was doing this, I clearly didn't clean up the surface of the stud or the bung well enough. So gave it a quick file this time round so that we can try and get a better weld in there. I'm going to try and put a bit more heat. I think that the weld is just about maxed out, but I'm going to try and put a fraction more heat in there to see if I can get a bit more fusing going on. same thing. Right, well that's still nice and warm. Nope. Nope. I think we might be drilling these out. So I tried a few different ways, we're not really having any luck getting these bungs out, so something I didn't want to have to do, but I will do. We're going to pull the turbo off the engine, so cracking the 4 bolts off this flange here, hopefully nothing seized there, and then undoing this and then pulling the turbo off the engine gives me a chance to seal up the turbo, and then I can start drilling and doing some sort of work to these studs. Yeah, I don't have to pull the turbo far away from the engine, I just have to get it far enough away so that I can protect it from getting any crap inside it.
Next week, we lift the lid off a mystery box. Jess gives us a hand in the engine bay, and Damien blows his cork.
Where will you go? Won't you miss the ones you know? I'll be here hanging